Here we're going to prove that the sum of the first r squared numbers is this here. Now this is actually just the proof of the first square numbers, and we're going to do this using induction. Now if you're new to induction, I'm just going to talk you through all the processes. The first thing is that we try the first number. So we put 1 squared into the summation form, which gives me 1, and I put 1 into all of these. So that gives me a 6, the 1 times 2 times 3, and in fact that's true. 1 squared is equal to this sum, which is 1. Now if you're doing an IB question on this, I know that this first step is just going to be worth a mark, so you can't skip that first step. Now the next step is to write out the statement, assume n equals k is true. So I'm going to substitute in here the k, so instead of having n squared, it's going to k squared. Just substitute in k instead of n. Now, depending on the question, depending on how the mark scheme, this is worth at least 1 mark here. And you can lose marks if you don't have this. Assume that n equals k is true. Now the next step is where I'm going to get a lot of the marks. This is the inductive process. So I'm now going to let n equal k plus 1. Now if I let n equal k plus 1, if I just stop here for a minute and I write out, if I make it nk plus 1, and what I want, and this is always handy to write down maybe on the side of the page, so I want to put k plus 1 in, I want to get the answer 1/6 k plus 1. Then if I put k plus 1 in here, it becomes k plus 2. And 2k plus 1, and then add another one, it's going to give me 2k plus 3. So what I want, and that's when I put the k plus 1 into there, you can just double check that. What I want to do is I want to do some process and end up with that mark, with that point there. So this is going to be quite important. I already know that if I add up all the terms up to the k plus 1 term, so that's all the terms up to k, I know that I've got this part here true. I've got all of that, and the next term is k plus 1 squared. So that's the sum up to the one I'm doing, and then this is the next term which goes into here. Now I'm going to go from here to here. So this is now just a bit of algebra. Now you can pause and have a look and double check my working. What I've done here is I've just made this second part here 6/6k plus 1, and I've expanded this out. Always keep an eye open on what you want, because now when I get to this point, I can see that I've got k plus 1 in here, and I've got 6. So if I take the k plus 1 out, I've got these first two parts here. And then inside the bracket, so I've got the 1/6 and the k plus 1. Inside the bracket here, I'm just going to expand, and then I'm going to factorize that. And this wasn't too difficult to factorize because I knew what I was looking for at the end. So this is just the algebraic manipulation. Now you're going to have a mark for just setting it up. You're going to have probably, then these marks are going to be in here for doing the application. So you can see there's 6 marks already. But the 7th mark is always at the very end, and it's for saying, as the proof holds for n equals k plus 1, it holds for all values of n. You're going to put this into your last line on every single proof. So we can see there's quite a few marks here, probably 7 marks for doing a simple proof like that. And there's some easy marks for here and for here, and then easy marks to miss as well.